Hi, welcome to Mr. Techpathy Tutorials. This is part 8 of Linux device drivers. Today we are going to learn about kernel symbol tables. As a part of kernel symbol tables, let's discuss about following topics. A symbol in Linux, how it is exported, symbol and symbol table relationship, and the idea behind exporting a symbol. So what is a symbol in Linux? In Linux, symbols are nothing but variables and functions that are needed to implement modularized drivers. Note that each and every symbol has its address in the memory. To make our understanding clear, let's draw a small diagram which shows a Linux kernel modules with symbols. Imagine this small diagram as our Linux kernel module which contains our variables and functions. We'll be using this diagram in our upcoming slides. So in short, symbol is nothing but a variable or a function in Linux kernel module. Exporting a kernel symbol is typically done with export underscore symbol, export underscore symbol underscore GPL. Export underscore symbol, which exports a given symbol to all loadable modules. Coming to the export symbol underscore GPL, which exports a given symbol to only those modules that have GPL compatible license. GPL here is nothing but general public license, which is widely used for free software license. Among these two functions, the first one is far more common. So what is the difference between export symbol and export symbol underscore GPL here? Export underscore symbol underscore GPL functionality is same as export underscore symbol, but it marks the exported symbol as usable only in modules licensed through either the general public license or compatible one. So whenever you write a driver, it should be a GPL licensed. That will be a great facility in case your module wants to use any other functions that are already exported using GPL. Now we know about a symbol and how it is exported in Linux kernel module. Let's learn about kernel symbol table, also known as symbol table in short. Kernel symbol table is nothing but a lookup table between symbol names and their address in memory. When a module is loaded into kernel memory using insmod or a modeprobe utility, any symbol exported by the module becomes part of the kernel symbol table. Exported symbols will become public kernel symbols. Let's represent this in a diagram. Here is the diagram which shows the kernel module and the kernel symbol table. If you see here, the symbols and variables are part of this kernel module, and a particular symbol, let's say a function 1 is a symbol in this Linux kernel module which will be exported using the function export underscore symbol. So the moment when you insmode this kernel module, it will try to export this particular symbol function underscore 1 to the kernel symbol table. Kernel symbol table will have an address, type, and symbol. We'll be discussing about these three parameters in upcoming sessions. So whenever you insmode a kernel module, whatever the functions or variables which are exported using export underscore symbol will be a part of this table, and this table will be used as a lookup table between symbol names and their addresses in the memory. To know more about this kernel symbol tables, the insmode utility resolves undefined symbols against the table of public kernel symbols. Kernel symbol tables hold all information needed to find program symbols, assign value to them, and relocate them. Primary task of symbol is to associate a string with a value. For example, printk symbol represents the address of printk functions in virtual address space where the function machine code resides. This kernel symbol table is loaded into the memory as a part of kernel boot process. Let's come to our final topic, idea behind exporting a symbol table. Whole idea of exporting a symbol is to make other modules benefit using them. New modules can use symbols exported by your module, and you can stack new modules on top of other modules. This concept is called module stacking. Now, let's say we have our Linux kernel module 1 and Linux kernel module 2. Whenever you insmode Linux kernel module 1, if it exports the function 1 using export underscore symbol. So this will be a part of our kernel symbol table. When Linux kernel module 2 is insmoded, the insmode utility tries to resolve the undefined symbol function 1 by referring kernel symbol table. It finds this entry and it will try to insmode this module successfully. So we will be stacking Linux kernel module 2 on top of Linux kernel module 1. Module stacking is implemented in the mainstream kernel source as well. Like each input USB device module stacks on the USB core and input modules. Module loading order can be important, particularly if they are stacked, dependent on the symbols defined in other modules. Without insmoding Linux kernel module 1, there will be no entry of function 1 in this kernel symbol table. So when we insmode Linux kernel module 2, we'll end up with an error. So the order in which we are going to insmode kernel module is very important, particularly if they are dependent on one another. This mechanism helps us to reduce the development time by simplifying each layer. Remember, Mr. Techpathy Tutorials is all about inspiring others to learn and share their knowledge. Let's learn, share, and make this world a better place to live. Thanks for watching Mr. Techpathy Tutorials. If you like this video, please subscribe this channel for more videos. Also, don't forget to give a thumbs up. Thank you.